Okay, in this problem we have an African antelope, springbok, and these guys can jump. So, and when they do, they have roughly an initial velocity of 7.0 meters per second. And we are asked to find the time that they take to reach the highest point, the time they stay in the air, and when they return to Earth, how fast are they moving? So those are the questions. So in this problem, we're going to use our steps, our prepare, solve, and assess steps. So let's start with preparing our problem. So here we have a motion diagram. So these are the velocity vectors. They decrease, right? So those are the velocity vectors. We have our acceleration, g, that points down. So we are going to choose a coordinate system that points up. So we are going to choose our 0 to be here. So this is our antelope right here. And then he jumps, and then it's going to be up here after some time. So it goes from this initial point to this final point, right? And then we want to name things. We want to name symbols. And remember, in this coordinate system, the acceleration is equal to minus g, right? And g is 9.8 meters per second. So let's start with the initial time. We can always set that to 0 because we can always set our stopwatch to 0. Let's keep going. Our initial position, the origin is 0, so well, that is 0, and an initial velocity that is 7.0 meters per second. So that is our initial time, the things that we know there. So let's see final. We have, well, our final time, we don't know, and that's actually what we need to find, the time that it takes to reach the maximum height. The final position, we don't know. And the final velocity, that we know. When it reaches the highest point, the velocity is 0, so this is 0. So now we can go ahead. This is our step in when we are preparing our problem. The problem is just, now we have a pretty good idea of what we need to find, this guy and this guy. So let's write our three equations. So we have y final equals to y initial, and I forgot to say this coordinate system, I'm naming y, plus v initial times delta t plus 1/2 a delta t squared. Now I remember that a, the acceleration, is g, so minus g. So then I'm going to write here, this is minus g. So that's my first equation. So I'm going to write my second equation, v final is equal to v initial minus acceleration, right, which is g, minus g is the acceleration, times delta t. And finally, we're going to have my final equation, vf squared is equal to vi squared plus 2 times a delta y. And remember, a was g, actually minus g, so I have to change this sign here. So that is my equation. So those are my three equations, and now I can see how I solve this problem. I want to find the final time, so that this equation here seems to be the better choice, so I'm going to use that equation. So I have final velocity is equal to initial velocity 7.0 meters per second minus 9.8 meters per second squared times tf, because delta t is, remember, delta t is equal to t final minus t initial, but t initial is 0, so this is equal to t final. So now I can find t final, and t final is equal to 7.0 meters per second divided by 9.8 meters per second squared. And then I can go ahead and solve for this, and this is 0.71 seconds. So that is my first answer, and so it makes sense. I mean, these things jump, but then they stay in the air about a second, so that's pretty good. So how long does it stay in the air? Well, it's gonna stay in the air. It goes up and takes 0.1 second, and when it comes down, it's gonna take exactly the same amount of time because the motion is symmetric. So the time that it takes in the air is 2 times Tf, which is equal to 1.42 seconds. And finally, what is the speed that it has when it reaches the ground? Again, the speed here is 7 meters per second. Well, the speed here is or the velocity here is going to be in the other direction, but it's going to have the same magnitude because the motion is symmetric. So then the speed is going to be 7 meters per second when it reaches the ground.